Hi, Mitch.
Hello.
How are you tonight?
Good. How are you?
Good. Gearing up for your final? Have you taken some already in other courses?
I took my cooking and woodshop final.
Okay.
My 2 easy final.
Okay. So you got your tough ones coming up, huh?
Yeah, I have my 3 tough ones tomorrow.
Okay. Well, shall we start on question 24 here?
Yeah, and I don't need to actually sketch the graph. I just need the other stuff.
Okay. What's the elementary function?
It's
What's
just
the parent function?
It's just the absolute value of x.
Uh-huh. So what's going on with this one in the way of transformations?
Is it moved to the right?
Yes.
5?
Yes. In other words, it's always x minus h. No matter whether you're talking conic sections, vertex format for a quadratic, translations, it's always x minus h. So h here would be a positive 5. Positive means to the right. And what's the 2?
Up 2.
Okay. What's the parent function here? Well, parent is the same on all 3 of these.
Yeah.
Okay, so what's going on here in B?
So it's flipped over the x-axis,
Okay.
and then right or left 1, and then down 4.
If you're going to sketch it, what's important that you do first?
Flip it.
All the reflections. All the reflections. No matter whether they're vertical or horizontal. What is happening in the thing I just drew? What is that?
It would be, wouldn't it be to the, it would be pointed to the left, wouldn't it be?
No, it would just be a reflection over the y-axis. In other words, when your negative sign is in front of your parent function, it's a reflection over x. But when the negative sign is inside, in other words, if I'm looking at f of minus x, the moment I'm looking at f of minus x, that is a reflection over y. Okay? Now, having said that, notice the absolute value function is that, so if it's at the origin and you reflect over y, it looks the same way. It doesn't change its appearance. Of course, if it's not at the origin, it would matter. But, okay, and what's going on in C?
It's a vertical stretch by 2, and then it's flipped over, and then vertical stretch by 2.
Okay.
And then move left 4, and then down 1.
Okay. Is that the only thing on this page that we had?
Yeah. Like, I didn't really get just the function family. Like, what does that mean?
All right.
Is it function?
There are 10 elementary functions. There is the linear function. Y equals x. There is y equal absolute value of x, which is this function. There is y, let's see if I can list how many of the standard functions. There's that, there's x squared, there's x cubed. Each of these is a different elementary function. There's log x, there's y equals some b to the x, there's y equals sine x. You should have had most of these. Is there anyone there you're not familiar with?
Log x.
Log x looks like this.
Oh no, we saw that.
Yeah, you've seen that. It's the inverse of e to the x. In other words, the b to the x graphs like this, and this is actually an inverse function of the exponential function. So if we want to consider just the 8 elementary functions, we could look at this group here. I may be leaving one off, but I can't think of what it would be. So whenever we're talking about something being translated, then it's some variation of this. In other words, if I said, what's happening here, what's happening?
Is it just moving right one?
In other words, this elementary function looks like this. But this function starts 1 unit to the right and looks like that. So no matter what function they give you, it's almost always a transformation of one of these 8 parent functions. What's happening here?
It's moving left.
And it's a parabola. In other words, this is the parent function. So your keys here are to discover what the parent function is, and then figure out how this is different than the elementary parent function.
All right.
All right. We want to do some of these completing the square.
Yeah.
Just left a student's house, and I saw these same problems. What's the first step if I'm going to complete the square? What would the normal process be here? Let's just say they said solve this.
I would factor it.
Except it's not factorable. So what would you do then?
Quadratic formula.
Correct. And both of those, you kind of start from this position, right? Well, when we complete the square, we don't start from this position. We want to move the number to the other side. So in that regard, it's completely different than dealing with a normal quadratic. A normal quadratic, we'd put everything on one side, try to factor it. If we couldn't factor it, we'd plug it into the quadratic formula. But if we're going to solve this by completing the square, we're going to put the number on the other side, and the only thing I'm leaving on the left are the x squared and the x term. Now I'm ready to complete the square there. What do we need to add right here? And it's always adding.
Don't you don't you divide 10 by 2 then
Square it.
square?
Yes. So what is that number?
So 25.
Okay, if I write 25 there, what do I got to do to the right side?
You have to write 25 too?
Okay, now it's exactly the same. Nothing's changed. It's still the top formula. But the beauty is that because I have completed the square, I can write that as how? A linear term squared. What's the rest of it?
So it's positive 5.
It's always whatever you got when you took half of b, that's what goes there. Now that's equal to 28. So what's the next step?
And then you would...
If I told you that x squared was equal to 9, how would you solve that?
You take the square root of both sides.
Okay.
And
So do it here.
so you just take the square root of both sides and that.
What do you get?
X plus 5 equals the square root of 28.
What's missing from that answer?
Plus or minus.
Simplify that square root of 28.
Oh no.
What are factors of 28?
4 and 7.
Okay, there's a perfect square in there, 4.
Okay.
So
So
go ahead.
the square root of 7, or the square root of 7 times 2?
Yeah, or 2 root 7. You tend to write it with the real number in front. Okay, now the last step is to move the 5 over. There's your answer. Notice how similar that answer looks to what we would get if we'd have plugged something into a quadratic formula.
Yeah.
Only it was probably easier to do this. Completing the square is not particularly tough. Let's do another one. Let's do 41. First step. In other words, after you try to factor it and after you decide you don't want to go through the quadratic formula, you decide, well, I'm going to solve this by completing the square. Because there are 3 ways to solve a quadratic. There's the traditional way where you factor it, there's the quadratic formula, and then there's completing the square, a 3rd way. So what's my first step?
You move 28 to the other side.
Now complete the square on the left.
Then plus 36.
What do I have to do to the right?
Add 36.
Rewrite and simplify.
So it's x minus 6 squared. Then plus 8. And then it's just 8.
Okay. Next.
And square root of that. So x minus 6 equals 2 to the power of, or 2 plus or minus the 2 plus or minus that.
Last step.
X equals 6 plus or minus 2.
Yeah. And we write it like this. Rather than adding the 6 to the end like that, it's a good idea to leave it in the format that you're used to seeing these answers for quadratics. In other words, had we used the quadratic formula here, this is exactly what we would have got.
All right.
You need to do 42.
Yeah.
Okay. First line.
So x squared plus 20x equals negative 104. And that'd be x squared plus 20x plus 100. Then 100.
Ooh.
And then x plus 10 square rooted, or squared. And equals negative 4. And then it's x plus 10 equals 2i.
Very good. Plus or minus 2i.
Okay.
In other words, you still have to add the plus or minus even though it's an imaginary number. And then the last step.
It's negative 10 plus or minus 2y.
Okay, good. And let me just throw one additional one at you. And what's different about this?
It has the 2 in front of the x squared.
Yeah, the x squared coefficient is not 1. And that's a special case. If it's not 1, you have to make it be 1 before you can complete the square. So how can I make it be 1?
Take 2 out of everything. So it's x squared minus 3x equals... What? You wouldn't take it out of the other side too?
No. In other words, what I just wrote is exactly what I started with.
Okay.
That's all that matters. So all we're doing is rearranging it. Now let's complete the square. Inside the parentheses only.
Alright.
And you always are adding.
So it's adding, so it's 1.5 squared.
About 3/2 squared. 9/4. What do I have to write on the right side of the equation?
9/4.
What did I, when I wrote,
Oh no, you.
when I wrote 9/4 in, how much did I add to the left side of the equation?
You added 18.
Okay, so I got to add 18/4 over there. Now, there is one thing, a slightly different possibility here that might make things a little easier. When I get to this step, I can divide both sides by 2. So immediately I turn that into a 5. Now the problem becomes this. And you can see that's the same equation as I started with. I just divided both sides by everything by 2. And now when I complete the square, I don't have to worry. In other words, I'm still going to add 9/4, but now I can just add 9/4 over there. I don't have to add whatever 9/4 times whatever it was being multiplied by. And now I can write this as x minus 3/2 squared. This would be 7 1/4. Okay? So,
Yeah.
I kind of like this method a little better, to tell you the truth. I hadn't realized I was not doing that when I did these before. Once you factored that thing out, you can then get rid of that by dividing both sides by that and simplify it into a little more doable, a different complete the square that's not as easy to make a mistake on, put it that way. Because it's pretty easy to make a mistake when you factor that number out and then when you're trying to balance the equation.
Yeah, that's it for that.
That's it? You got anything you want to
So,
verbalize?
Just
What's average rate of change mean?
like, what do you mean? Like how fast something was going up?
I'm trying to think of an example. Average rate of change means slope.
Okay.
It's the change in the rise versus the change in the run. In other words, let's say we had a graph here. And our graph looks like this. What's the average rate of change between 5 and 10?
it would be
What's the rise?
10.
No, the rise is the vertical change. So we're looking
So
at the difference between that and that. So that's 50.
Oh, 50.
Divided by the run, which is 5. That's 10 per. In other words, for every 1 unit on the x-axis, we're going to go up 10 units on the y-axis. And notice that I got an average rate of change, which was the slope, and we don't even have a straight line. But if I connect my two key points with a straight line, that 10 is that slope of that straight line. So when you see a problem, I saw a problem on your other sheet there that was asking about average rate of change. Just find the slope between the 2 points.
Oh, okay.
Okay? In other words, it doesn't matter if this is a curved line. When I said what's the average rate of change between 5 and 10, just make a straight line between 5 and 10 and then figure out the slope of that line.
All right. I actually don't have anything else
Okay? Well,
because I've had so many sessions with this.
yeah, I know. I expect you're actually going to do pretty good. I expect you to do real well. I can't think of anything that you don't know at the moment. In other words, I'm trying to think of stuff we've covered where you were a little weak on, and I can't think of anything. All right. Well, good luck tomorrow. I hope you survive it tomorrow. It's like me surviving today.
Yeah.
Up with 7 hours of sessions today. It's my busiest day of the year. Let's hope I still have a brain at 9 o'clock tonight.
Wait, do you not have very many people tomorrow?
I don't. I have like 2 sessions tomorrow, and then I have 2 on Thursday. But most everybody's final is tomorrow, so everybody slammed me on Monday and Tuesday with sessions.
Yeah, everyone from Chatfield or all the Algebra 2 have their finals tomorrow.
Yeah, I think it's like that pretty much all over the state. And I'm not sure why I even have 2 sessions tomorrow. I don't think those people's final. I think one of them has his final the next day, Thursday. And that's one of my appointments tomorrow. All right, well, let's see. I assume we will not meet again until after the holidays?
Yeah.
Are we going to stay on a Monday, Wednesday, Saturday schedule?
Probably like, cause
Maybe not the first Monday, huh? Because the first Monday will be,
Yeah.
that'll be the first day back.
no, we don't even get back that first Monday.
Okay, so do we want to, since I got a minute or two here, not much more than that, but let's look and make sure we know which day we're coming back here. I am guessing that you go back to school on Monday, January 5th?
I think we have like Tuesday. I think we get back Tuesday because Monday
Okay.
is like a teacher work day.
Let me kill that.
And-
Let me kill that Monday appointment.
And I actually don't think I'll need it that first week we get back anyways because
You want to cancel all 3 of these? Okay.
Yeah.
That's fine.
And then I don't think I'll need the Saturdays anymore
All right.
until
I don't have other people wanting Saturday appointments, so I'll leave it there for the time being, and you can just tell me at our next Monday. So our next session is going to be Monday, January 12th at 6. Does that work? And then by then, I think you'll probably have a better feel for how many sessions you want. You can just let me know then. All right. Have a happy holidays and good luck on your tests. I'll talk to you on the 12th.
All right.
Bye-bye.
Thank you.